To the new episode of GitHub Copilot. In today's episode, we will look on unit test development with the help of Copilot. In the previous episode, we covered unit tests using JUnit and Copilot. Today, we are moving to Java unit testing framework, JUnit based unit test development using Copilot. We touch upon parameterization, exception handling, and mock frameworks as part of today's Copilot demonstration. So without any further ado, let us move to the application. So we have a very simple Java application called calculator. There are few methods: addition, subtraction, and multiplication. So it's a simple methods are available here. Let us start adding the unit test for this one. So going to the test method and asking the Copilot to add unit test here. Add unit test for the add method. So it's able to detect the add method and able to add one unit test here. So most of the time this kind of testing, the simple test cases will work fine, but at the same time as a developer we may need to test the functionality with a multiple set of data. For that we use a parameterized testing. So when there is a parameterized testing, you can pass not a single value combination, multiple values to the test cases. So let us see how Copilot can help us in parameterized test generation. Add parameterized unit test for the add method. So it's not able to detect the parameterized word. It may be because the imports are missing or none of the other test files contain a parameterized test cases. So as a developer, I know that the parameterized test needs to start with parameterized test. This is the attribute I need to use it. So let me select that one and go ahead. So let me import this class, and when we go to the next one, it start giving a CSV one. So let me take the CSV source to define the data points. Then go with the test method. So again we need to import the class for this particular CSV sort. So this is a parameterized test generation. You have a parameterized test attribute. Then inline source I have used a combination of input and output. So it takes that values here to input and what's expected one. Based on this value, the test case is properly generated. If we run this test case, it executes for all these values. Around 10 different values are there. Right now all values are positive values, so it's passing. So let us make some modification and see whether it's able to execute or not. So this particular test case is supposed to fail because of the expected values are wrong. So it's expected 13 but actually is 43. So this is how the parameter test case generation is. But again, sometimes we may have the test data not as an inline data. It should come from an external data, something like this. You have the inputs and the output defined as a CSV file or any external file system. So then we need to have the data reading from this one. So let us prompt Copilot to get a test case based on this one. So again add parameterized test for the add method or subtract method using, we have a CSV file. Either we can specify file name itself. So let me just give a CSV file, that's a closure. It understand there is a parameter test now and it needs to go for the CSV source. But it's again defined this way, inline sources. So let me just prompt it again, CSV source or file source. This is what I needed. So it's able to identify there is a data.csv exists here and link to that one and generate the test cases. So let me just import this particular class as well. So it's having two. So as there is one test case already here, I need to rename the test name. That is fine. So this defined a parameterized test case based on the data coming from the CSV file. So we have around 5 different data points. So let us run this one now. It execute 5 times. You can see some of them is negative test cases, some are positive test cases where it's passed. And even we can prompt it to skip the heading kind of thing. Give a comma, then the Copilot is able to identify the clause required. So number of lines to skip. If you have a heading in the CSV file, you can skip it. So I'm going to skip 2 lines, means execute only for the remaining one. Skip the initial 2. That is the indication. Normally we use this for the skipping the heading. So you can notice here only 3 is executed right now. Now coming to the test case generation, sometimes we may need to handle the exception blocks as well. The overall test generation angle, we talk about the coverage area. So if I run with a coverage, it gives you the coverage here also as well. The code coverage comes here. You can see there is a 33% of the methods covered, only test. Add method test is written right now. So when there is a exception handling blocks, we need to handle that as well for a better coverage angle. So let us go and add one method with exceptions. So I am adding a method, add a method to divide two numbers along with exception handling. So this is what I needed. So it need a divide method and it's a give an exception handling also. Arithmetic exception is there. So this is the method I just added. So let us try to get a unit test. Add a unit test for the divide method to cover exception handling. So test is done. It's divided something. So this is not covering the exception handling area. So let us again prompt Copilot. It went for a parameterized unit test, but I don't need a parameterized unit test for this exception handling. Instead of that, I will ask for generating the exception itself. So what's the exception it's thrown is arithmetic exception. So let me prompt Copilot to add unit test for the divide method to handle arithmetic exception. So it's defined a test and I am again prompting, this is what I am expecting. So arithmetic exception is expected. So if I run these two, this is without exception. Here there is a B is 0, that indicate it covers the exception block. If I run these two, it covers the entire block of divide 1. So let us see how to run this one, which is the exception area. It's done. The exception is occurred. If you go here, so I need to run with coverage to show whether it is done the coverage angle. So you can see this green line indicate that this exception block is completely covered by this test case. So this particular method, divide method, have a coverage, almost complete coverage is done. You can run this positive test case so that it cover the entire areas. So what we discussed till now is a simple unit test generation, parameterized unit test with inline code, as well as the parameterized unit test with the CSV file, and also the exception handling blocks. So if I prompt now the parameterized one, so add unit test for subtract method, or I can say add parameterized unit test for the subtract method. Now the system is able to give me the parameterized test clause and also CSV1 and the test cases. The reason is we already have this context here and the corresponding imports are already done. So any new prompt will provide me this entire blocks. So there is no need for me to prompt as a developer. So in the initial time when we start developing the unit test, as there is no import happened, no clause defined or attribute defined with parameterized, you maybe need to give that suggestions or handle that entry initially. After that, Copilot will be able to support you. So let us move quickly into the mocking area. So for mock, we are going to do a to-do service here. I have an interface to-do service with a which retrieve a set list of strings, and the implementation area, there is one method related to Java, and it's directly called the to-do service, but nowhere it is implemented. So if I want to test this one, I need to mock this to-do service dot retrieve to-dos method. So how to do that one? So let us go here. There are a lot of things are required here. We need to start with implementing the annotations. So let us do that one, import angle and run with annotation. So this will import the two elements required. One is the mock, the other one is run with, and this one. So now let us add the attribute here, add run with attribute. So I need this attribute to prompt that this particular test class will be using Mockito as the mocking framework. Now we have the attribute ready. We are going to create the mock object. So create mock object for the to-do service interface. So it's start with mock to-do service, this one. Either we can go with this way, or you can say this equal to new mock, or the mock of, or just service is enough. So I am just accepting as it is. Now mocking is done. Now we need to create the object for the to-do implementation. This is also done. Now let us create annotation with the before method. So any test case starting before that, we need to set up it. So you need to create an object of service implementation by passing this mock object. So mock object is passed to the to-do business. So anytime we call this to-do service, it use this mock object. So that's what it's doing. Now let us try to add a unit test. So let me add unit test for the retrieve to do related to Java method. That is the method. I am going to do test. Let me see how it's coming up. It's done with some sample statement. So I am just removing this one. I need only this one, to do service using the mocking. Now let us add the mock data. Add the mock data. So to do there is a data is created and we are passing to this one when. So Again, I need to import some classes here. It's not taken. Let us complete it. When we call service.mock, then use this particular to-do list. That is what it's doing. Now call the method for testing purpose. So it's done the retrieve method and then assertion is also done. So the method is completed. So there is few imports I am missing, so I need to import these elements. So let me import these things. There is import this one, and when also needs to import it's need to import the class. When is part of our JUnit only. So let me see what needs to be imported here. Assert equal is done. Add when method. So when is also done. So this is the mocking framework where what exactly we did is there is no implementation for to-do service. Instead of that, we mocked the implementation of to-do service and passed the data here. So, and whenever we refer that to-do service anywhere inside this business implementation, use this mocks data and return the value accordingly. So let us run this one. It's successful because the to-do related to Java will return this learn Java 1 entity, and the expected is 1 number, so the size is matching. So let me embed one more data with the Java here. Java. Now this will fail because the return value will have these two values. So you can see actually is 2, but we are expecting 1. So this is how the mocking works. Mock framework also supported by Copilot. You can enforce the mock based test case development as well using the Copilot area. And now let us move to a services angle. When you have a Spring Boot based service, so normally it gives you kind of APIs. So here the controller is giving me a customer entity. The return value is a customer value. So sometimes we may need to test such things using JSON based data points. So let us go ahead and see how we are able to get the customer API one. So I am asking add unit test for the get customer API method. So there is a get customer API method which needs to give some unit test. So let me just complete this one. The expected value, local port, some assertion is done. It's done. So if you notice here, it's created an expected value randomly as a string value and get the data out of my customer entity and asserting it. So before running the test case, I need to run the demo application. So I'm going to run the demo application. So it's running on 8080. Let us take one prompt and see how it is running. Local 08080 hello world and /customer. This is our API. These are the values coming up. Okay. Now go to the test case and run it. So this may not be meeting the requirements. So there is a customer ID is fine, and name is fine, but the address is not correct, or phone number is not correct, email is not correct. So it's failed. The test case is failing because the expected value is this one, but actual value is this one. There is a mismatch between these two. So passing the string in this format may be little difficult. So we may need to use the JSON based models. So let us start with initial one. Unit test and unit test for the customer API method using JSONAssert. Assertion we will change first. So again test, another one. So let me just complete this email, and it's done the one, and it's doing the assertion anchor. So if you notice, this JSONAssert is the element we have used. Either we can import this one or directly use it here. So instead of converting the output into a string class and comparing the string based comparison, you can go with the JSON based assertion. Again, here also the expected value is defined as string. So let us again prompt, I need the expected value also as JSON object. So add a unit test for the customer API method using JSON object and JSONAssert. So test, no, it's again giving this expected one. So I need to start giving a prompt. So let me start the JSON object. So there is no JSON object as of now in this class. So let me go and add it. So it will be part of this one. Let me try to import here. Import JSONAssert is done, and the JSON object. So it's able to get it. Now let us see how it's able to form the JSON object. Customer ID, first name, last name, zip code, email. This is the structure it's taking and comparing both the things, expected and actual. So it's able to assert whether JSONAssert is able to do it or not. So even I can remove this one and see this one, assertion is done or not. So the expected value, again for the conversion angle, I need to convert it into string because this is a JSON object. The output coming from here is a string. So convert it into a string and compare with the actual value. So with the proper prompt, in terms of, we started with a simple prompt, direct unit test for customer API. Copilot is able to give the expected value and the comparison or the complete unit test based on the defined controller, customer controller. This is the controller we used. Based on that, it's able to give it. Similarly, when we ask for JSONAssert, it's able to again fine tune the code and give a JSONAssert based assertion. Later, JSON object, as there is no object earlier, so it's not prompted. As a developer, we prompted, then it start putting together the structure and came with this one. So we have one more method here, credit rating. So let us see how we are able to get it. This time we have the JSON object and everything. So add unit test for the API method using JSONAssert and JSON object. So test it, and it's created the object. If you notice, it's directly taken JSON object and the credit rating, what's the rating expected, and return values. This is what we have in the controller if the credit ID is good, bad, unknown. So it covers these test cases here. It's returning a good rating and comparing that one. In case the credit rating, even you can observe that the entire routing and everything is taken care properly. It's a credit rating, it's here also credit rating. So this value is tested properly. So once you have the context already available, there is not much prompt required. The Copilot start understanding the context, and based on your prompt, it gives you the output. So overall, Copilot can be used for JUnit based unit test development in terms of parameterized testing, exception handling, mock framework, or JSON payload angle. So go ahead and explore it. Let us meet with another video soon. Thank you.